All right. Welcome to the talk, Attacking Storage Services, the Lynchpin of Cloud Services. Myself, Anant Shrivastava. I'm Technical Director, Not So Secure Global Services. Let's have a quick look at the agenda that we have for the day. Or how I like to call it, how I'm going to bore you for next 30 minutes. We'll start with a quick overview of cloud storage. Then we'll look at some of the real-world attack scenarios. We will then talk about the attack methodology that we can follow. What are the ways to prevent these kind of attacks? And then we can open up the session for in question and answer. A quick introduction about myself and specifically trying to convince why you should listen to me. I am Director, Not So Secure Global Services. In my span of career, I have dealt with system administration, development, and right now doing a security day in, day out. So effectively all shades of IT is what I've gone through. I like to do a lot of open source projects. So I'm the project owner for right now Hacking Archives of India, Android Tamer, and Code Vigilant project. I like to contribute a lot to the open communities. So Null, Garage for Hackers, Red Team Village, n number of open source community and open communities that I contribute to. Anant Shri, ANANT SHRI is my handle, which is the handle I use on almost all of the social media platforms. Now, let's get straight to the topic at hand, the cloud storage. Now, cloud storage is an interesting piece of cloud puzzle. If you look at it from the top vendors perspective, you have AWS S3 Buckets, you have Azure storage, you have GCP storage, and a bunch of other vendors provide different kind of storage solutions. Now, if you expand the purview of storage services, you would end up including SharePoint, OneDrive, Dropbox, Google Drive storage, even stuff like AWS Code Commit or code repositories like GitHub, Bitbucket. All of them are essentially storage services provided by different vendors. Now, what do they store? You could store a file, you could store a document, you could store a source code, you could store transient objects. So for the time being, you want this object to be stored, you can use storage for that purposes. I've also seen, I don't know why, but I've also seen people storing their SSH keys inside storage or various secrets inside storage. Now, if you've paid attention to the heading of the slides, I've used the word linchpin. So linchpin, or basically the anchor, is how I like to call cloud storage. So the cloud storage is the linchpin for cloud services. Why do I say that? Because consider cloud storage as an external disk connected to your laptop. Just like you keep data in that external disk, that is exactly how cloud storage operates. Now, a large gamut of cloud services are actually offered because they have decoupled the data storage. Now, almost all of our cloud services are going to rely on cloud storage. Things like, let's say, function as a service or platform as a service, they don't even have source code in a specific system. Source code is actually stored in a storage container. And that storage container is reused whenever they need to spin up another version of the application or another version of the function. Similarly, secret storage and bunch of different functionalities besides just the file storage are part of cloud data store. Now, when cloud storage is keeping a large gamut of information and large number of things, it becomes the central key piece for the entire cloud offering, which means if you have higher level access over cloud storage, you can do massive damage to the organization, to the environment. Now, why should you listen to me? Let's look at a couple of examples. So this is an old article. but it highlights very clearly how much of a damage happened because of Amazon S3 services being publicly exposed. So all of these entries that you see here are actually S3 buckets which were publicly available. And right from Booz Allen Hamilton to WWE to Dow Jones, everyone had their S3 buckets open to public. Now, 1 year after this article was published, another study was done, and this time they basically discovered that of all the buckets that are there in the world, or at least in their study, 10% of the buckets were public in nature. Out of those 10% public bucket, 20% of them were world writable, which means anyone across the world can actually write to those buckets. Again, what could be the problem? That storage can then be used for n number of purposes, but more importantly, the person had access to store the data in there or remove the data from there. Which brings us to the question, what's the big deal? Why does that matter? So let's look at a couple of case studies which are showing direct impact on different organizations. For example, this one, a 2016 case study. This is where HackerOne, which is surprisingly a security firm or a firm which manages bug bounties for different organizations, had their S3 bucket writable by any authenticated user. We'll come down to the nitty-gritties of what this authenticated user means, but effectively, anyone who was logged in on AWS was allowed to write inside the S3 bucket. The report is public and it is linked there. So although the bucket was not allowing you read access, but it was possible to put the files inside it, which can then further be leveraged for, let's say, social engineering purposes. That, hey, I uploaded a document in a location, or hey, do you see a XYZ docx file in a certain location? Can you open it? And then all the social engineering based attacks can follow from there. More major impacts. This one. This was Rocket.chat, which is a chat application. They had their installer, and the installer was referencing to an S3 bucket which was not registered. So the ethical hacker in this particular scenario actually claimed that S3 bucket, and then they were able to plant entries inside it, which resulted in this particular scenario. As you can see, when that installer was executed, you get an error message. Now, this was an ethical approach, so this was reported, fixed, and moved on. However, if someone wanted to do a damage, this is where a damage could have been possible. Anyone running a Rocket.chat installer would probably give pseudo passwords in, because guess what? They're trying to install something and they need to provide higher level access so that the execution can be done. Another interesting case study, and this was a fun one. So Linux has always had a problem that firmware vendors were not providing updates. So the firmware vendors came up with this approach called LVFS, or Linux Vendor Firmware Service, where there is a binary FWUPD which runs on all the systems. It periodically checks whether there is a firmware update available. If it is available, it will show you the update and you can install that update. Now, again, a similar scenario, it was referencing to an S3 bucket, which was not claimed. Maybe it was deleted before the researcher came into picture, or it was never claimed at the first place. Now, at that point, they claimed the bucket. However, there was one more step in the picture. If they provide an update via the S3 bucket, the update has to be PGP signed so that Fwupd will accept it as a valid update. This is where they found a PGP signature bypass vulnerability. Combining these two, they had access to that bucket for 26 days, 2.5 million update requests with 500,000 unique IP addresses. You can look at the potential impact that could have been possible just because a storage was not claimed and someone else was able to claim it. Which now brings us to the question, I get that this is problematic. I get that we need to do something about it. But what? So this is where we are now going to look at the attack techniques. But before I talk about attack techniques, let's just quickly revisit the responsibility distribution between tenant and the vendor. And for this particular purpose, nothing beats this particular diagram, which is called Paas as a Service 2.0. This outlines how different environments differ from a traditional on-premise environment to infrastructure as a service, to container as a service, to platform as a service, moving on to function and software as a service. Now, the key ingredient in all of this is that no matter which area you talk about, conversations, or in our environment, the configuration is something that you will have to bring to the table all the time. What does it translate to in the current environment or in the cloud environment? Identity and access management and the data is always going to be a tenant responsibility. And that's where the major problem is. So, how do you attack? Or how I like to call it, why more than half of you are here and want to look at this? Now, we've seen at different case studies that attacking storage would give us higher level of privileges and allow us to do a bunch of different things. So how do you go ahead and perform this attack? Now, the methodology that I like to follow is a very simple attack methodology. You enumerate and gather information, then you identify vulnerabilities. Once you have identified the vulnerability, you exploit them, and as part of post-exploitation, you may end up pivoting. If you do post-exploitation or pivoting, you are back at step one because now you are in a new environment. You again enumerate, gather information, and you keep going through loops of this particular methodology. So what do you do in terms of attack? When you want to enumerate, there are a couple of things that you have to be absolutely clear about. Storage names are unique for the whole of service provider. So if I have claimed a bucket called Anant in one region, the entirety of cloud service provider cannot allocate that name to any other tenant. So the names of the bucket are unique. What that means is that the organizations need to find a unique name they can register. How does that work out? In most of the situations, organizations are going to append their name, their nickname, or their unique characters as bucket name. So if the bucket is supposed to be assets, and let's say a bucket is supposed to be secrets, it will become example assets, example secrets, assuming example is the company name that we are talking about or we are targeting. So even though it is a unique name, even though everyone can claim whatever name they want to claim, the first approach that goes is the organization would append or prepend their names in the bucket name, which for an attacker makes it predictable. So you can have a list of words, append them or prepend them to the keyword, and then you'd be able to brute force them. Now, The thing about tools is there are n number of tools available around this particular scenario. I'm going to cover one or two of them, but they keep on changing because nowadays people like to build tools, and it's a good thing everyone wants to write their own tools. So you end up having large number of variations and options. So I've mentioned two URLs right at the slide, which are pointing to awesome asset discovery list that Red Hat Lab maintains. And they have two sections, a cloud infrastructure discovery and a domain subdomain discovery. Both of these can help you in finding various buckets. Now, buckets could either be directly accessed via their vendor-specific URLs, or they could be CNAME aliased to the domain. In both the situations, the tool list that is provided would be able to find those buckets. Now, there is one tool that I definitely like to mention. It's called Cloud Enum. Now, this particular tool exactly does what I talked about. It takes a keyword, takes that keyword, builds a mutation list. The mutation list contains various keywords, appended, prepended, and then it checks at all the service providers. So it checks at, or rather all the top service providers. So it checks at Azure, it checks at Google, it checks at AWS, and then it also does another layer of steps. Like, for example, if it finds a storage in Azure, it also looks for what could be the container name. If it finds the storage in any of the service provider, it is going to try and see if it can be accessed as an open bucket. And you can see here, open S3 bucket, open Google bucket were the messages that were provided to me by the tool itself. That, hey, for this keyword that you've provided, there are buckets which are open, and here are the files within those buckets. Now, a quick overview of how different buckets operate and how you can access them. AWS buckets generally are accessible as s3.amazonaws.com/bucket name or bucketname.s3.amazonaws.com. Now, with these URLs, you can perform brute force because they give you different error messages. If you want to access the buckets via REST style URLs, which is what I've shown here, one key ingredient that you need is the region keyword. Now, this is interesting. You need the right region, and then only you can access the buckets. However, the error messages on AWS gives you those regions. For example, if you see here, the first call was made to s3.amazonaws.com and the bucket name. It said the bucket you're attempting to access must be addressed using the specified endpoint, and it ended the message. What I did in the next one was s3 dot any random region. So instead I kept US West 2, and it responded back, the bucket you are attempting to access must be addressed using specific endpoint, and it has listed the endpoint, the correct region. Now this bucket belonged to US East 2. So now I know the exact region of the bucket, and now I can access it. Besides these, what are the other avenues by which you can find these buckets? One of them could be a cloud bucket URL scraper. So this cloud scraper tool, it actually looks at your website, scans through the entirety of the website HTML code, and tries to identify various places where you might be making calls to a cloud storage entity, and it will list out those. Similarly, you have Grey Hat Warfare, which is basically a big search engine for Amazon public buckets. And you have the good old Google Docs. You can do a search for s3.amazonaws.com or core.windows.net. This is AWS Buckets. This is Azure Buckets. And here, if you see, I've done a very clear search looking for S3 buckets in whatever region with keyword AWS_secret inside it. And we've got 102 results. Some of them would be dummy data. Some of them would be not what we are expecting, but some of them would most definitely be valid AWS keys. And then that can lead to exploitation. Here again, you can add more keywords in your Google Docs and focus attack on one specific client if you want. Now, let's say you enumerated different resources. Now you need to identify weaknesses and you need to exploit them. Remember the responsibility matrix that I showed you? The two things that tenant always have to take care of: data and access permissions. And that's exactly the area that we should be focusing on. If the bucket has anonymous access granted, which is public for all, or it has misconfigured write access, example was that authenticated user allowed, or it has IAM rules or policies giving access to data, which should not have been possible. Let's look at a couple of examples. So Azure has a SAS URL concept. This storage access URLs allow you to access a specific storage with a certain set of permissions. Now this is a very popular method among Azure users or Azure developers to share the bucket data or specific files within the bucket. Now if you see here, the example URL that I've given has multiple keywords which I've highlighted in bold. What do these keywords mean? So this is where we basically did a big blog post around exploiting leaked Azure storage keys, and the table that I've taken is from that blog post, where we have identified and outlined what each of these parameters meant. The two parameters which are, or rather three parameters which are very important for us: SRT, what kind of services are allowed; SP, the level of permission that we have; and the expiry date. Now, I said that these are very popular among developers. Here is an example: 64,479 hits for default endpoints protocol keyword on GitHub alone. Now, what do you do if you have access to a URL like that? You can use Microsoft Azure Storage Explorer, and you can pick this option, use a shared access signature or a SAS URL. And in there, you can provide the URL here. It'll autofill all the other ingredients. If you don't want to use Azure Storage Explorer, you can do things manually. So you have the Azure storage that you want to access. If you want to do a listing of what is inside the container, you can do this parameter, rest type container and comp equals list. Or if you want to access a file, you can just do the container name and the file name. Remember, this has to be in conjunction with the other parameters which I've listed here. So SV, SS, SRT, SP till SIG, all of this would remain as is, because contrary to what people might think, the SAS URLs are container level URLs or storage level URLs. They are not URLs pointing to one specific resource. So even though you might have a URL pointing to a JPG file or a PNG file, but the same URL with the same signature would give you access to the entire storage. And that's kind of what we did here, where we found a Azure storage SAS URL. Once we got access to that URL, we loaded it into Azure Storage Explorer. We were able to see all the assets, what we found was within the same container or within the same storage, there was another container which was keeping the source code for an Azure function. And the SAS URL that was created gave us write access. So how did we attack this? We were able to download the source code. We were able to plant a backdoor inside the source code. And in the next invocation of that Azure function, when a copy of source code was taken from the bucket, my backdoor was then executed in the function namespace, which means I had a different level of access available because I was able to plant a backdoor within the Azure storage. Again, very detailed blog post is available here. You can have a look at it if you want. So we got access to data. What can be done? So I've given you one example of what we did. That's one very clear example. We have done it times and again around function as a service or platform as a service. If you have application source code level access, you can plant a backdoor inside it, and that backdoor would then allow you to access the data. Now, the sensitive data in the bucket in itself could be way more than what the company valuation might be. You can find secrets such as passwords or key within the buckets, or you may end up just getting Office documents. Even if that's the case, you can do credential harvesting. You can look at these official documents to look for usernames, the softwares that are used to generate these softwares or generate these documents. I've given a couple of examples. Fwupd is a specialized tool which is built for this purpose. You load documents, it will extract out metadata and give you the final list. If you don't have Fwupd running, which is a Windows-only tool at this point, you can use this Unix utility which is available on Unix and a Mac environment called exif tool, and you can use these handy nifty one-liners, and you can look at, say, docx, xls, or PDFs, extract out the metadata from them. Now, a couple of more case studies around how exploitation could be done. In this particular scenario, we started with an SSRF vulnerability on a web application, which gave us access to metadata. Now, within the metadata, we were able to extract out security credentials. Using those security credentials, we had access to various S3 buckets. One of the bucket was conveniently named as PEM files. So there was a keyword minus PEM files. And when we looked inside it, we found around 200 different public key or private key, public key pair for different servers that this organization was running. Clearly name tagged with the server names. So all we had to do was extract out list of EC2 boxes, map the names with the PEM files, figure out which EC2 instance had higher level access role, and then gain access to that box using the PEM file. And we were in a position where we were able to create a IAM:* level user. Now, we did not document it publicly because around same time ThreatStack came up with an attack diagram which very nearly outlined the exact same procedure. So that's what you can refer, but this was one flow that we did from SSRF to EC2 takeover and effectively AWS account takeover. Now, platform as a service exploitation. In this particular scenario, again, the initial vector was SSRF, which gave us access to S3 bucket. Now, in this particular scenario, the S3 bucket was hidden from plain sight because we were not able to read the list of S3 bucket names. However, again, the predictability because by which the names are formed for S3 buckets for Elastic Beanstalk, we were able to identify the exact same naming pattern, and we were able to access the bucket. Again, once access to the bucket was obtained, we had access to the source code of the platform as a service application running. We were able to plant a backdoor. There was an automated CI/CD pipeline around the application. So within a few minutes, we actually had our backdoor deployed on the official website. Now, this is what we documented in the blog post here. This was then picked up by SummitRoute. SummitRoute discovered that what we found as a naming pattern for Elastic Beanstalk, that was not the only naming pattern. There were other places where a similar naming pattern setup was present, and they extracted all of that out and listed out in a neat blog post. Similarly, AWS Cognito. Now, Cognito is a service which allows you to have credentials. Now, there was a bunch of different things done in this. The important keyword for us to look at is, when this research was performed, they had access to 2,500 identity pools, and of those 2,500, they got access to 906 S3 buckets which had sensitive information. So they got access to a large number of buckets, but these 906 buckets were the ones which had sensitive information inside it. So now you can relate, the storage environment had a larger data pool, and sensitive information is very commonly stored inside these storage environments. So the purpose of showing you these case studies was to give you a perspective around how attacks could be mounted with regards to the storage environment. When we look at the attack around storage environments, the general idea that we go with is, we target the storage from the onset, that we would get access to a storage and then we'll do XYZ things. However, a storage-based attack could be a middle point also. You may get access to an environment and that opens up the storage for you. But because all these various entities need to be stored in storage and exploring the storage becomes a key component of the attack that you are going to plan on your cloud environment. Now, defenses. So we've talked about attacks a lot. We've seen multiple case studies. Let's talk about defenses, or things everyone should do but no one cares. So from a cloud vendor's perspective, effectively what they can do is provide warnings and provide automation, which if you select, allow you to mitigate these problems. Tenant has a larger gamut of responsibilities here. You need to look at identity and access management. Who needs to get access to the bucket? Who does not need to get access? Ideally, public access would not be required. If you are not clear, authenticated user is not the setting that you want. In almost 99.99% of the scenarios, the role access has to be either private or public. Authenticated user level access provides no additional protection, so no point picking that as the access privilege. Now, besides configuring these things, you need to be prepared from 2 points. One, you need to carefully recheck all your settings on a periodic basis. And two, you need to be aware of the limitations that you have. I'll come down to the limitation parts in a minute. Now, from a vendor point of view, vendors are doing their bit. Like, for example, this is AWS giving you a warning when you're trying to create a bucket. By default, they're not even allowing you to make it public. This is by default checked, which means the buckets are not allowed to be public by default. However, people generally uncheck it or change the settings later on without realizing what content is available within the bucket. Similarly, the SAS URL, you can see this big caution is there in Microsoft documentation saying that, hey, this is a critical entity. Do not share it. Do not use it as your daily media of access. Do not share it with friends and family. This is critical, but people don't read, or people don't read the right things at the right time. Now, things like AWS Config, which is a service provided by AWS, have started to come up with these automated rules. Like this particular rule that I'm showing you runs every 24 hours or whenever there is a configuration change that happens. Looks for S3 buckets if there is public write access in them. Once it finds it, you have options. You can do automatic remediation. You can do manual remediation. Automatic remediation again has a bunch of different options that you can try, which could be removing public read-write access on the bucket. So if the bucket is not supposed to be public, it was made public by error, automatically AWS config will kick in and will stop the bucket from going public. How can you validate all of these? One, you can run periodic scans like Scout Suite, CS Suite, and a bunch of other options are there, which will perform a cloud level audit. Now, I don't have one single tool which is storage focused. So what you need to do is you need to run these auditing tools and look at the storage dashboards within them. Like in this example, S3 storage. So we've looked at how to perform the attacks. We've looked at how to perform protection, how to do validation around it, what kind of validations we should be doing. Now comes the last part, which I like to talk about before I close my talks almost all the time. Be prepared for the inevitable. What happens when an attack is going on? And this is very specific to the blue teamers, to the people who are going to provide protections. You need to be in these areas. Things that you are aware of, others are aware of, or things that you are aware of, but others are not aware of. You don't want to be in the blind spot zone, or you don't want to be in the unknown zone. Now, what do I mean by these? We were talking about AWS Config a few minutes earlier. AWS Config is a tool which allows you to perform periodic checks on your buckets. What's the periodicity of it? When a change happens, will it prevent the bucket from going public, or will it revert the public bucket back to non-public? If it is going to revert, how many minutes it is going to take? What is the minimum time? What is the maximum time? If you are not aware of these values, you may end up in a situation where you assume your protections are working, but they are actually not working. This is where there are a bunch of ways to do it. One of the emerging tech that is coming up, or keyword that is coming up, is called chaos engineering. You may want to apply that, but effectively, when you have prepared for a disaster, or when you've prepared security measures, you need to validate whether those measures are actually kicking in or not. So simulate a hack, see the reactions of your system, and if those reactions are not up to the mark at which you wanted them to be, then go ahead and fine-tune those. Find out alternatives if the need be, and then revalidate it again. So this is the point where I am now open to take any questions. I would be looking at the Discord chat and answering questions there. Before I close the talk, a quick reference to two links which are useful all the time. Jason Haddix has an awesome bug hunter methodology series. That's the GitHub link where you can find. So a lot of the tools that I've talked about or I've referenced are all featured in this link. And the CloudSec wiki is something that we are preparing. We as in Not So Secure is preparing. Again, a wiki very focused on cloud security and puts out links, references around cloud security. So that's all from my side. Thanks again for listening so long. I'll be available on the Discord channel for any question and answers. Thank you.